Hi guys, in the previous session you learned about objectives and outcomes of the subject of artificial intelligence. Next, we are going to enter into the syllabus. Welcome back to the series. Today's session is what is agent and what is intelligent agent in artificial intelligence. Let's get into the topic. An agent is an entity that perceives its environment through sensors and acts on it through actuators. Let's think of it with an example. A human also can be an agent. How can we sense? We can sense with eyes and ears. And what are the different actuators in human body means hands, legs, vocal tract, these are the actuators. In the same manner, coming to the machinery robotic agents. So here in place of eyes and ears, we use cameras, infrared range finders, and these are like a sensors. And actuator is motor. And another agent is software agent. Here all inputs we get with the keystroke, file content, network packet, and here the result is output. Here the output can be displayed through screen display, file writing, network communication. Sensor and actuator does the work, but what unites them all? Their ability to act based on what they perceive. So, between the perception and action, the bridge is a agent. The thing is how the agent become intelligent. And what is the definition of intelligent agent? An agent's decision depend entirely on its percepts. The information it gathers at any moment, its complete history of percepts called the percept sequence. So the percept sequence guides every action it takes. This means agent act based on what they have seen, heard or experienced, never on unknowns. The diagram, agent uses sensors to perceive the environment, and next based on the perception agent take the decision, and next based on the decision the actuator works. For explanation we take the example of thermostat. Suppose agent observes the temperature by using sensor, means it perceives the temperature from the environment, and next according to the low temperature agent take the decision, and the decision is that turn on the thermostat. So actuator work on it in the environment by taking the action that turning on the thermostat. Agent is making own decision. It means agent should have a behavior. For the decision making, agent uses percept sequence. To make it as a function, we map this sequence to mathematical table. At its core, an agent's behavior can be described mathematically by its agent function. This function is like massive table mapping every possible percept sequence to the corresponding action. For real-world agents, these tables are often infinite unless we define specific limits. The agent function is an abstract idea describing what the agent should do for any input. On the other hand, for the software implementation, we use the agent program. Of its real world implementation, a set of instructions running within a system. Together, they make the agent come alive. Like agent function is an abstract idea and agent program is a implementation of a software. Both make it as alive. Take the classic vacuum cleaner agent. It perceives its location and whether there is a dirt, it finds dirt. It sucks it up. If not, it moves to other square. By tweaking its agent function, we can create smarter or dumber versions of the vacuum. This simple world illustrates how agent behavior can be designed and evaluated. And next, What makes an agent good, intelligent, or even useful? This is the big question artificial intelligence seeks to answer. It's not just about what agents do, but how well they do it and how adaptable they are. Let's explore this further. What does it mean for an agent to act rationally? In artificial intelligence, a rational agent is one that always does the right thing. But what exactly is the right thing? It's all about the consequences of the agent's action. A traditional agent evaluates every decision based on the outcomes it generates, striving to achieve the best possible result in its environment. A rational agent is an intelligent agent that makes decisions based on logical reasoning and optimizes its behavior to achieve a specific goal. When an agent acts, it changes its environment. These changes result in a sequence of states. If the sequence aligns with the desired outcomes, the agent has performed well. This is where the concept of a performance measure comes in. An objective way to evaluate how desirable the environment states are based on the agent's actions. Designing performance measures is tricky. A poorly defined metric can lead to unintended behaviors. Imagine a vacuum cleaner agent judged by the amount of dirt cleaned. It might clean the dirt, dump it out, and clean it again to score points. A better performance measure rewards keeping the floor clean rather than just cleaning up repeatedly. What makes an agent rational? Four key factors come into play. The first one is the performance measure. What defines success? And the second one is the agent's prior knowledge about the environment. And the third one is the action it can perform. And the fourth one is its percept sequence. The percept sequence is the history of what it has observed so far. A rational agent uses these four factors to choose actions that are expected to maximize its performance. In simple words, the rational agent focuses on how good it does, but not how maximum it does. Again, let's see the example of vacuum cleaner agent. Is it rational? Let's see. It has a simple function like clean a square if it's dirt and move to the next square if it's clean. Here we are using two conditions. If it's dirt, if it's clean. If it's dirt in the square, it should clean. If it's clean, then it should move to the next square. But is this agent rational? Let's see. It depends. Let's assume it scores 1 point for each clean square at each time step. Next, it knows the layout of environment but not where the dirt is or its starting position. And the next, its actions are limited to moving left to right and cleaning. Under these conditions, this agent is rational because it maximizes its performance measure by checking whether it is clean or dirty. And one more thing, rationality is not fixed. It adapts to new circumstances. If movement incurs penalties, the agent should avoid unnecessary escalations because it is moving around squares and squares means it wastages the electricity. So it consumes more electricity. If the room is clean also, again it goes and checks whether the square is dirty or clean. Again it rotates to the next square and it moves to the next square. So it consumes more electricity. To avoid unnecessary escalations, it should take a wise decision. But there is also another case that if that can reappear, it must periodically recheck and clean as needed. Rational behavior depends on context, and intelligent agents must adapt to meet these changing demands. One is it should not do overconsumption of electricity, and another one is the dirt may reappear. So the decision should be wise. Defining rationality is not just a technical challenge, it's a philosophical one. What's better, a consistent but mediocre performance, or one filled with highs and lows? How do we balance trade offs in real world scenarios? These questions push the boundaries of AI and help us designing agents that can truly think and adapt. Follow us for more updates and next topics. Thank you for watching.